start recording. Okay, so we are ready to look at module 6. So module 6 is down here. It looks like there's more here than what actually is, but I wanted to go over and kind of give you an overview of what we're going to be doing here. So you're going to notice by the title, it says that we are going to be looking at assembly modeling, kind of putting everything all together. So the first part here is the learning plan, and we're going to be focusing on chapter 14 in our book. Okay, so we will be going through the tutorial that's in there for the support shaft assembly, or I'm sorry, the shaft support assembly. Now, in the tutorial, it does have you create 3 detail parts or 3 models. Instead of taking time to do that, they're relatively simple models. I already generated those for you, and you can go ahead and download these 3 parts right here. Okay, that way we don't have to take time to go through and model these. We'll just use them to then create the assembly down below. So I'm going to give you a couple minutes to download these 3 files. I suggest putting them in a directory where you can recall them, like in module 6 or something like that. And then we are going to be navigating to those. So know where you're putting them, so we can navigate to them to create the assembly. So just those 3 parts you need to download. And then we're going to be generating not only the assembly model using those 3 parts, but we're also going to be creating an assembly drawing with a bill of material, balloons, all that kind of stuff. So you can see that. Now, just like we've been doing for all the other modules, we're going to have the practice problems, and those practice problems are going to be the shaft support assembly model first, and then the drawing. So 2 things to hand in there. And then we're going to have the assignment 6 broken up into 4 parts, and we'll talk about that when we get there. Okay. So the assignment is going to be an application of the stuff that we learn here in chapter 14. Okay, so I'm going to go back a level. So that's the learning plan. That's what we're going to be looking at. Then you're going to notice there's going to be a place here for populating as we do our recordings here. I'm going to be populating them in the session recordings. And then we've got the drop boxes for the practice problems first. And then we're going to, have the 4 assignments. Again, it's really 1 assignment broken up into 4 parts. So it's more easily organized, if you would. Okay, so we are going to, I'm going to go underneath my camera right here, and we're going to start looking at chapter 14. So chapter 14 starts here, assembly modeling, putting it all together. And what we're going to be making here is going to be this assembly that we see here. This is called a shaft support assembly. There are three main parts, but then we've got some hardware, if you would, that we're going to be adding. So we've got this angle base plate. We've got I think this is called a bearing, and it's got 2 flanges. And then we have a collar that's in the middle here. Okay. So 3 main parts that we're going to be putting together. Those are the 3 parts that you're just downloaded from the Canvas site. And we're going to be seeing how we can put those together. We call them mates. We're going to be mating those together. Now, as we look here, this tutorial starts on page 14.4. And the first part here, as I stated earlier, is to create these parts. Okay. Again, you don't have to do this part. They're actually quite simple parts. I didn't think we needed to really go through that. You guys have had plenty of practice. So that's going to be the first couple pages here. We are not going to create the cap screw. We're actually going to be using, SolidWorks has something called a toolbox where we can pull out standard hardware. I'm going to show you how to navigate and use that toolbox for standard pieces like fasteners and such. So we won't be creating that, just the 3 main parts. And then here is where we start the tutorial for actually an assembly. Now, I'm going to open up my SolidWorks. Some of you already have done this because we've talked about it, but I'm going to go underneath to SolidWorks. I'm going to open up. And this time, instead of, you can kind of see here, instead of picking a part, we're going to be picking the assembly template or the part that you can go into. So if you're getting this welcome menu here, you can click on assembly. It's just going to be a generic assembly. But if you do get the template format available here, you're just going to click on assembly here. Okay, it's really just that simple. So just click on assembly and you can click OK. And now this is going to look very similar, but not exactly the same as what it does when we start a new part, because now we've started a new assembly. Now you're probably going to get this navigation box to open, but I'm just going to, before we go there, I just want to kind of show you how things are a little different. Up on the top here on our ribbon, you're going to notice that there are different tabs. And the very first tab when we're in creating an assembly mode is assembly, okay? And it's asking us right here, because we started an assembly, it wants to know, okay, we need some parts, right? That we want to pull in here. And so it's wanting us to begin the assembly. And here it's asking us to browse for the parts. And that's why this dialog box is open for you. What you want to do now is you want to navigate to where you just saved those 3 parts, okay? So I have mine in my module 6 shaft support assembly tutorial. That's what I have my directory, but you might have it somewhere else, whether it's in the downloads folder or on a jump drive or someplace else that you're saving. And you should see the base plate, the bearing, and the collar available, right? Now, there is an order to how we're going to pull things in and how we're going to do an assembly. And I'm going to go back to the actual assembly that we're going to be doing. So I want to kind of point right here. So on page 414, this is the orientation of kind of that 3D mode of the 3 parts together. When we pull in our first part in an assembly, it's usually the first one that when we would physically assemble it, it's going to be where we start, okay? And there usually is an obvious piece for that. And in this case, it's going to be this base plate that we see right here. That's going to be the first part that we bring in. The next part we bring in is going to be something that's going to be connected to that part that we just chose, which is going to be our bearing. And then the last piece that we're going to pull in is going to be our collar. Now, ours is relatively simple, but we're going to be able to kind of, really get used to that assembly process by just using these 3 simple parts. So our first piece that we're going to pull in is going to be, I believe it's called the base, right? Yeah, the base plate. So I'm going to go back to SolidWorks over here, and we're going to be pulling in this base plate. Okay, so I'm going to click on that, and I'm simply going to say open. And this is the part detail, it's like the part model. So it's just the model. Now, when it comes in, it's going to be on the end of your cursor. So before you even click, it's right there for you. And just by left clicking, we're just going to place it. That's all that we're going to do. So we're going to left click and it's going to place. Now, when it's the first part that's coming into your assembly, it's going to be what we call fixed. It's going to be constrained and it's going to kind of be sitting there. You don't have to do anything else, but just place it on your screen. Okay. So our first part is in place. As we look over here at our design tree, the design tree looks a little different. You're going to notice that it has the name of the file on the top here. We haven't changed it to our formal name, which we will do in just a minute, but it's called assembly 1. All right. It's kind of like that generic name, just like when we pull in a part, it's just calls it part 1 or part 2 when we first come in. And then down here, you're going to see that it has our familiar planes, our origin, and then right underneath there is the first part that we just pulled in. Okay. We're going to notice that as we pull in more parts, there's going to be more values that come underneath there. We can expand out this part. And now this is going to be what it would have looked like when we did the individual model. So notice that this is all the information, the planes and all that kind of stuff and all of my features underneath here. Okay. So I'm not going to expand that. I'm going to keep that closed, but that's what you see underneath there for our base plate. Okay. Now we want to pull in our next piece. Okay. So again, thinking and looking back, the bearing was the next part that would have been like placed on top of here. So again, thinking about how you would actually put this physically together, the order. So now we're going to go up and on the top on our ribbon, there's a place where we can insert components. So we're going to click on insert components. It's automatically going to go back to that same directory that we just picked that base plate out of. Okay. And that should be the same place where we see the bearing. So I'm going to click on the bearing model here and I'm going to say open. And now you'll notice that here, I've got it on the end of my cursor. I'm going to use my roller and just roll out a little bit. And I'm just going to place it kind of in space above this. Now, don't go over the top of it, just kind of over and up. And I'm going to left click and I'm going to place it. Now you're going to notice that the bearing is now on my design tree. Okay. Now, something you're going to notice that's in front of it is the parentheses minus. What that means, it's like underdefined, just like it was in the part model, but it means that this can move around in space. If I left click it and move it, it's going to move around. If I left click and move and try to move my base plate, it is not. In front of it, it says fixed. That's because it was the first part that I pulled in. It kind of like anchored everything else around that first part that you pulled in that's fixed. But this one, I need to figure out, okay, I need to anchor it or mate it to the other parts here so that it's going to be where it's supposed to be. I can't just put it here and say, oh, right about there, and now it's in place. No. We're gonna have to align things and mate it. Now, before I do that, a couple things. Let's save our assembly so that we get the right name up here. It's the Shaft Support Assembly. So I'm gonna go up to File, Save As, navigate to where I wanna go. If it has this message, you can rebuild and save the document. That's totally fine. And I am going to call this the Shaft Support. I'm going to call it ASSY because that's the assembly, and I'm going to call it 1. Now, do it all in caps because just like we did for part prints, when we pull it in and we create an assembly drawing, the description is going to then pull from this part name. And if it's not in all caps, you'll get points off because all text on any drawing has to be in all caps. So make sure that you have it in all caps, what you're calling it. And then you're just going to say save. And now we're going to see the name at the top here change to what you just saved it to. There's no asterisk because now we're in current with the save. Okay. Now our goal, and I'm going to tell you about instances when this isn't the case, but for most parts, we want to get rid of that negative sign. We want to mate it so that it's not moving around in space. Okay. So we are going to add some mates here. Oh, before we do, let's do something fun. So I'm going to select on, left click on my base, and I'm going to go up to the edit appearances in our heads up menus up here. Okay. And I'm going to click on that. And this gives me the option to change the color of that feature. So for the base, I'm going to make it dark blue. Okay. You can pick whatever color you want. And I'm going to go to the bearing. I'm going to do the same thing. And I'm going to change the color and I'm going to make it red-ish. Okay. So that's how you can change the color. I think it's nice to do it, especially on assemblies, because then you can see where one part ends and the other part begins. If they're all gray, sometimes it's not obvious what the individual parts are. So changing the colors is kind of nice to do that. All right. So now what I'm going to do is I'm going to go in and we are going to mate our bearing to our base. Okay. So, so we are going to simply go up on top and we're going to click the command mate. Okay. We're going to click mate. Now it wants us to know, it's asking us over here what we're going to mate. So we need to select something. So as we look at this part, I'm going to kind of roll it around here. I want the center of, I'm pointing to the left, like countersunk hole on our bearing, to align with the hole, which is a threaded hole in the base plate. Okay. So how I'm going to do that, I'm going to zoom in here a little bit, and I am going to select on the inside surface. Don't select on the edge, select on the inside surface. So you see like a cylinder going down of that counterboard hole. So like the through hole part. So I'm going to select on that. I'm going to select that. And it selects the face number 1, it's called. And then I'm going to do the same thing for that left-hand hole in my base plate. Select the surface, not the edge. And now what happens is it is going to make those two coincident. Now, in this case, SolidWorks is going to assume. So it's looking at, this is a cylindrical feature and a cylindrical feature. I'm probably going to make it concentric. And that just means that they both share the same center line, which is exactly what I wanted to do. So if I roller this around, this over here, is it going to let me move that? It's not. It's up here. So as I move this around, my surfaces aren't touching yet, but this is in alignment center line wise. Okay. So I'm going to hit okay. I'm going to accept that. That looks good. Now, if I look here, and I left click on my bearing and I try to move it and rotate it, notice that it will stay in alignment with that hole, but it'll rotate around that and I can move this up and down, okay? So it's not fully constrained and we want to get it fully constrained. So the next thing we're going to do is we're going to do another mate. We're going to say, okay, this hole on the right-hand side, the counterbore hole, and the other threaded hole in the base, I want those aligned as well. And you probably saw it shift. And now those two are in alignment. So if I click on my bearing here and I try to rotate it, no longer rotating because those two center lines are in alignment, but I can move this up and down, okay? And I can't shift it back and forth or in and out, but I can go up and down. So now I need to mate that. I need to figure out how I can mate those. And what I want to have happen is I want the bottom of my bearing surface. I clicked on that. Sorry, I'm going to do that again. Go back to mate. Hold on. The bottom of my bearing surface right here. So you'll notice when I float over the top of it, I get a surface. If I get close to an edge, then I get a single edge. But I want the entire surface. So I'm going to left click on that. And you're going to notice over on the left-hand side, it says face. And I'm going to rotate this around. I want that to be in contact with the top surface of my base plate. So I'm going to hover over it and left click. And now it's going to move it down so that those two are in contact with one another and make them coincident. Okay. I'm going to hit OK.
What happens if I didn't have to do that after I put the second inside cylinder?
I'd have to look at it. If you left click on it and you have only those two there, it's going to move up and down. So you must, unless you click something else, I'm not sure. I'd have to see. So then I'm going to hit OK. And now what we're going to notice is we're going to be out of that mate command. And now you'll see that there no longer is a minus sign in front of my bearing part because now it's fully constrained. Meaning I can't, if I go over here to left click it, I can no longer move it around in and out, rotate it, nothing. It's locked down. It's constrained. It's fully mated. Okay. So that's going to be the goal for most of our parts, not all. Okay. They don't have to be for some, and I'll tell you when that comes up. All right. So the first two here, fully constrained, fully mated, they're fully defined. Okay. Not a bad idea to do a file save here. So we've got our first part mated. The last part that we're going, or I should say the first two parts mated. The last part that we're going to be doing is we're going to be adding the collar to sit on top here. So we're going to go to insert part. Our directory is going to come back up. We're going to click on the collar and we're going to say open. And it again is going to be on the end of my cursor. Okay. So I'm going to kind of move this around and I'm just going to left click and place it in space. Okay. Bring this over. Now you're going to notice that our collar is kind of sitting there at a funny, way. So what I want to do is I want to orient it as close to, not perfect, as close to the orientation it needs to be in where it's going to be placed. So to do that, I'm going to left click on the collar in the design tree. You're going to notice that we get like this navigation, these arrows going up and down, and we also get these like swoopy radiuses. What that allows us to do is it allows us to, if we click on one, we left click and we drag it, it allows us to move up and down in the Y direction here. It allows us to move along the X direction linearly and along the Y. But additionally, if you go on any of these radiuses here, so if I click on a radius, do you see how it now rotates it around that radius? Okay. If I go on one of the other ones, it rotates it this way or the other way. And you'll always get these for your parts when you click on it in the design tree. Okay. And then so what I want to do is I want to orient this so it's sitting something like this. So that little shoulder is underneath here and that bore is like going vertical. Okay. Once I'm done with that, I can just left click on the side and then I'm going to change my color as well because gray is boring. So I'm going to left click on my color. I'm going to go up to change the color and I'm going to make it green. There we go. You can make it whatever color you want. But again, it just gives us that sense of seeing definitively where one part starts and the other one begins. So now I've got this in this orientation and I'm going to go back to mates because I want to mate this to the top of my bearing. So I want to mate my collar to the top of my bearing. So the first thing I want to do is I want these two inside diameters to be concentric. So I'm going to click on the inside surface of one of them to the inside surface of the other. Okay. And now mine moved over to be concentric. Now I'm going to accept that because that looks good. But now notice that they occupy the same space. So just like before, it's not fully defined yet. So I can take this and I can simply move this up and but it's going to remain in alignment, or it's going to remain concentric with the 4 down below. Okay. Now the next mate that I can do, because I'm still in mate mode. Now what I want to do is I want this bottom of this shoulder right here on my collar to be in contact with the top of the shoulder on the bearing. There we go. And it's going to make those coincident. All right. Now, if SolidWorks assumes the wrong thing, and it can, then you just want to pick the correct one over here. But coincident just means I want those two surfaces to be in contact with one another. So I'm going to hit OK. You just left click on the actual feature, and then you drag it up and down. Yep, you're welcome. Okay, so now this one is here. Now I'm gonna hit my mates. I'm gonna be done with it. And you're gonna notice that my collar has a minus sign in front of it. Okay. The reason it does, and this is where some parts you want and some parts it's not as important. This collar is a circular feature. Okay. So where we didn't lock it down is if I take this, I can actually rotate this around. All right. If I go on this one and I try to rotate it, I can't. And that one is fully defined because there's 2 axes that are keeping it from rotating. But this one, there was only one axis going down. And so even though I can't move this up and down anymore, I can rotate it. And that's what it's missing as far as fully defined. Could you change that? Sure. Do you need to? No. How could you change it? If it's like, I don't want the minus sign there, I want it to be fully defined. This is not required on a circular part, but I'll show you how you can do that. So I can go to mate, and you'll notice that there isn't a flat on it or a feature that I can align. So what I can do is I can go up to the eyeball up here. I want to change the visibility, and I want to see my planes. Okay, so I think it's the one on the right. Now I'm going to see the front planes. Okay, and what I'll notice is the front plane is going through here. This is for the support shaft assembly. I want the plane for my collar to be the one. So that means that over here, I've got to expand this out and I've got to go down to the collar. So do you see how on the shaft support, I expanded it out with that little triangle, and I'm going to move this over here. And now I've got to go down to the collar and expand it out. Okay. Because now what I want to do is I want to show its right plane, or I'm sorry, it's, yeah, the right plane, the right or the front, whichever one. The front is fine. I want to show that front plane. And now what I want to do, oops, not the front plane, I'm sorry, top plane, I guess. Top plane. I want the top plane, because that's the one that's going through here. I want that top plane and the front plane of my assembly. Okay, I want those to be parallel. Now, again, you don't have to do this. I'm just kind of showing this if it's something that you want to do. And then I'm going to hit OK. And then I'm going to hit OK again and go out of my mates. And I'm going to stop expanding that. And notice how my collar now is fully defined, because now what I've done is I've stopped the rotation around the axis. Functionally, it changes nothing. All right. But some people are like, I want everything fully defined. Okay. But in this case, when you have circular parts that are about a single axis, you don't have to fully define them, because all it is it's the rotation, and it's fine. Yes. You have to be on the right plane of the collar. So you have to expand out the collar. Okay. All right. so that is that. I'm gonna check the chat really quick. I didn't want to interrupt, but I think it's worth mentioning. You can also lock the rotation. Oh, can you? Okay, you know what? Let me look there really quickly. I'm glad you said that. So, so let me go into mates. Oh, is it right here with the lock? I've never done it with the lock. I wonder if I can just select that part and lock it. That's another way to do it. So you would select the collar right here, select it, and then you can just hit lock. And then that way it'll be locked as well. That's, yeah, when you do the constraint, lock the rotation is an option. Yep. Thank you. There we go. Oopsie. There we go. Okay. Thank you. That's another way to do it as well, or align the planes like we saw earlier. Okay. So, so those are our first three parts and we have those in place. Now let's look back at, our assembly. And you'll notice that to keep our bearing in place with the base plate, we have two fasteners that we want to put in place there. Okay. Now in this tutorial on page 14.7, they actually did and created and drew a cap screw. We are not going to do that. We are going to use SolidWorks, and it has a toolbox to actually insert this hardware. Now, to know what type of hardware we need to look at our base plates. Okay. So on the base plate, you're going to notice that there are two threaded holes here. These two threaded holes are called out as 3/8-24. So that's the thread of the two holes. So our fastener is going to have that thread. Okay. Additionally, it's important to note that from the bottom of the head to the end of the fastener, it's 3/4 of an inch long. That's going to be how long we're going to specify our fastener to be. So it's going to be a 3/8-24 UNF, or Unified National Fine Thread call out. And then the length of the fastener is going to be 3/4 of an inch. Okay. So we're going to find this in SolidWorks toolbox. Okay. So we're here in our assembly and we want to look at the toolbox. So up on the top here, I should say over on the right-hand side, we're going to click on the design library. Underneath the design library, there is something called the toolbox. You simply want to click on the toolbox. You're going to notice it probably says, oopsie. You're going to notice that it probably says add in now. Go ahead and do that. It doesn't always add it in because it saves on the time to like open up SolidWorks. So if you're not going to use the toolbar box, it doesn't make sense to always open it up. So you might have to do that. Now you're going to notice that there are a number of folders here. We want to first select ANSI inch. So this is like the United States inch. And then under here, there's going to be more folders that are going to have basic categories of hardware. The first one is going to be different bearings. The next one is bolts and screws, jig bushings, keys, nuts, O-rings, power transmission elements, retaining rings, structural members, and washers. Okay, so those are our options in this toolbox. What we want to go to is we want to go to bolts and screws. So we're going to double click on that. Then inside of there's all different ones. There's countersunk head, hex head, leg screws, machine screws, miniature screws, miscellaneous, round head, self-tapping, set screws, socket head cap screws. That's the one that we want. Okay. I'm going to show you something. And this is, you don't have to look back in your book, but you'll notice that the type of fastener they have here is a slotted head. When we're out in industry and we're making things, unless you're working for instance, a product that you're making for a residential purpose. So for instance, like a guard on a refrigerator or on your washing machine, you will not see slotted head screws when you're building machinery like automation equipment. They're normally going to be a socket head cap screw, which means that there's going to be a socket head on it like an Allen head wrench. Okay. The reason for that is because you need an actual tool in order to tighten or loosen it up. A slot head, you could use a butter knife, you could use a coin, and you could actually remove it. But by OSHA standards, when we're dealing with, for instance, guarding, especially in an industrial setting, or any type of machinery, we need to have an actual tool to tighten and loosen it up. And that's why we see socket head cap screws used a lot, or those Allen heads or torque heads, rather than the slotted heads. So always avoid slotted head fasteners or screws for that reason. So what we're going to pick is we're going to pick the socket head cap screws. Oopsie, let me see. Is that down here? Socket head screws, right? Double click. And then we're going to pick the socket head cap screw. Okay. Now this procedure is a little wonky, so just kind of watch me for a second. I'm going to left click and drag it into my graphics area. So I'm going to left click and drag it in. Okay. And then that menu goes away. And once I release that drag, the side panel is going to populate. And this is where I'm going to configure my, my fastener. Okay. So you're going to notice here, they're going to have properties. I want to pick 3/8-24. So you just hit that down arrow there and you're going to find where 3/8-24 is. Okay. You're going to click on that. So that's the size of the thread. Then the length is going to be what we had said, 3/4 of an inch. So you're going to find where 0.75 is. Okay. The drive type is going to be a hex, so that can stay there. The thread length is going to be 3/4 of an inch, and that's standard. When you start getting longer, that's when they make them smaller, but for 3/4, they make it the entire length. And then the display is going to be simplified. All right. That means that we're just not going to show the actual, threads themselves. It's just going to be a simplified thread. All right. And now we've got it configured. Okay. Then what we're going to do is we are going to click on the green arrow. And now you've got another one on the end of your cursor. If you need multiples, you just then continue to left click for however many you need. We just need 2. So you just need to left click one more time. So you initially bring it in from the toolbox and then you click a second time to bring it in. And then even though there's one on my cursor here, I just hit the escape key to be done with it, or X out up on the upper left-hand corner. Okay. So now I've got two socket head cap screws here, and I want to do that same thing that we did before. I want to align them. Okay. Or I want to mate them. So I'm going to go into the mates and I want the body of this screw, and you can pick either one. Oops, it picked the axis. I don't want the axis. I want the outside body, the cylinder, to then align with the cylinder of one of the through holes in our counterboard. Oopsie. Dang it. Mates, cylinder, and cylinder. There we go. And now you're going to notice that it aligned this. So I'm going to hit OK. And I can only do one mate at a time and hit OK. Now, a couple of things are going on here. Number one, it's now aligning that axis concentric. I can't move it back and forth or in and out. I can't spin it. That is all there. So that's in alignment, and I'm going to have to mate so that its shoulder is going to be down underneath. But I also need to turn it over. Okay. You can do that easily. There's that over here. Oops. I have to select the mates. Oh, I know. I'm going to select this surface right here. So make sure you zoom in and you select the surface. And then I'm going to select the surface down here. Okay. And what's going to happen is you're going to notice that it put the head in first, right? Both of those surfaces are coincident with one another, but it's in the wrong orientation. To simply put it in the right orientation, you're going to notice underneath here, it says mate alignment. Right now on the left-hand side, it assumed one direction. You're going to click the toggle on the right-hand side. And now what it did was it reversed it. And you can just hit OK here. And now you're going to notice that it's sitting in there properly so that the head is up rather than down. Does that make sense to everybody? We'll do that again on the next one. Okay. So we can hit OK. And now this is in place. The next one, we want to do that very same thing. We're going to click the body here. We're gonna click the inside cylinder here, and it's gonna do that same thing. You can do the misalignment at this point as well. Notice that it's here when I'm in my mate, so I can switch it to the other way, and now it just flipped it, okay? And it's down in here. So now that means that this is in alignment. So I left clicked it and I just dragged it up. I can hit OK. And then I'm going to do that very same thing. I'm going to take the bottom of that shoulder and the top of this shoulder. And now those are going to be concentric, and I can lock it at this point too. Oopsie. Yes. And then, there we go, to be concentric. There we go. Okay. So those are in there. Mine did too. I'm not sure what I did wrong there, but, and then I just did the concentric or the coincident. And like I said, you could align the planes if you wanted to, but you don't have to. And so when there's screws that are about a center, you don't have to fully define those if you don't want to. Again, functionally, it's not going to change anything. It's just that these minus signs are going to be here, but on the regular parts, you should. Okay, so now that takes care of all of the parts for my assembly. So we're going to want to do one last file, save, and then we can get rid of these planes by simply going up to our little eyeball and hiding them, okay, and just toggling them off. And I think it just looks nicer. It's easier to look at. So you're going to want to fit this to the screen and then do a final save. This is going to be the model. You don't have to expand out each one of these, okay? But I do want to see all the parts that are in there. Make sure that you include the design tree as well as the support assembly or the shaft support assembly title on top for your screenshot. And this is going to be the first screenshot that you use for the model in your module 6 practice problems, okay?